So you may have seen this circle in one of the slides, the first slides in the presentation. And so now that we have covered how to change degrees to radians and the other way around, this is that circle, okay? So I think the one I have posted has one of these. This is what we call the unit circle, and you're gonna see these throughout your pre-cal kind of trig review or introduction or continuation. And so what this is that all these angles are reference angles. Okay, we call these reference angles from the unit circle. And hopefully you're able to see some sort of pattern here that this is going by a certain number. Just pause the video and hopefully you're able to see what's the pattern in between all these quadrants. Okay, and so the way to get these pi over 6 and pi over 4 is by actually using those formulas to convert radians to degrees and degrees to radians, right? So that's why I introduce those formulas first, so that the circle now hopefully makes sense, okay? So 30 degrees means pi over 6 radians, 45 degrees means pi over 4, and 60 means pi over 3. Now, when you're studying trigonometry, when you're studying pre-cal, this is one of those things that you have to know. Okay, these are those one of non-negotiables. When I was in college, I don't know, I've always been a bit weird in regards to math. Like I don't want to say I was a nerd or that was really good at math. I've always liked numbers for some reason. I've always liked logic and very, factual things. So I loved trigonometry. Trig was one of my favorite subjects actually, with pre-cal and calculus. And so I memorized the whole thing, all these numbers with all the coordinates that you see in the other ones. But you really don't have to. And the way I memorized it was not every single one of them. If you memorize the first quadrant, like the first quadrant, you for sure need to memorize. You need to memorize what's the conversion between 30 degrees and pi over 6, and so forth. But it's just this quadrant, because this quadrant will build up, like the rest of the quadrants build on this one, okay? But I won't get into depth into these because we don't have enough time to cover these. But you will need to know, if your teacher next year says, okay, this is a sine of pi over 4, automatically you should know that pi over 4 means 45 degrees. So if you want to impress your teacher next year, now that you have a long summer ahead of you, maybe you want to memorize some of these angles, or at least the ones that are the most important. So the most important angles are definitely the first quadrant, okay? 0, pi over 2, pi, and 3 pi over 2. Those are the most important angles. And when I say angles, I also mean degrees and radians, okay? So your teacher next year will be very impressed if he tells you, or she tells you, so what is the conversion of 3 pi over 2? And then all of a sudden you say, oh, 270 degrees, right? Like, it's like, whoa, you really know the unit circle. And so maybe right now this looks really bizarre, but as you go a little bit in more detail into these next year, it will make sense, okay? But I do want to point this out, that this is very, very important for trig and for calculus and pre-cal. So the last part of the lesson is this one, okay? Estimate the degree measure of each central angle given in radians in a unit circle. Explain your reasoning. So basically what you need to do here is, from last class, we said that it takes about 3 radians to cover half of the circle and about 6 radians to cover the entire circle. So now that you have a better understanding of what a radian is and the unit circle as a whole, you can just give an estimate using the reference angles here from these from the unit circle to tell me how much it will be an approximation of the given radians that they're giving you. So for example, and by the way, 1 radian, if you use the conversion of the formula, 1 radian is approximately 57 degrees, 0.2, okay, 57.2 degrees. So with that in mind, I don't want you to use the formula here. I just want you to visualize it and just do the math in your head, okay? You don't need to go and do the formula. So if 1 radian it's about 57 degrees, that means that 2 radians is gonna be like 114, right? Something like that. And if I look at my reference angle here, I know this is very small, but if I look at my reference angle here, I'm gonna use it in degrees, okay? So my reference angle here cannot be 30 because we already said that like 2 of these, right? 2 radians, this is 1 radian by the way. So 2 radians will be like about here, right? And the closest reference angle that it's there, it's 120. Okay, so we can say that the degree measure of 2 radians is a little less than 120. Okay, and then here you can just give an explanation, but basically we just said that, right? Like 2 radians is 1/3 of 6 radians, and because of that we explained in the previous class, that 6 radians make up the whole unit, the whole 360, right, revolution. So that's what you have to do for this one, okay? You have to use the unit circle and your knowledge on radians to calculate the rest. I'll do one more and then you can continue with the rest. So for this one, I already know what 1 radian is. 1 radian, it's about 57.295. So I will just multiply 57.295 times 5 because it's 5 radians, and that is 286. So I need to position myself where here in the unit circle that's going to happen. So 286, it's greater than 270 but less than 300. So I will say that the measurement of 5 radians is a little less than 300. Okay, the degree measure of 5 radians is a little less than 300 degrees. And that's basically what you have to do for the rest of the problems. If you need to use the calculator for the bigger numbers, go ahead and use it, but don't convert it to degrees because that's not what I'm asking, okay? I'm asking you to give me like an approximation of how much that will be close in radians, close to a reference angle, and a little less or a little more, that will be good enough. I mean, depending on where you get it, right? Like you can argue, let's say that you get a number that's between 300 and 315. Let's say that is 312. You can either say the degree measure of whatever number is a little less than 315, but you can also say it's greater than 300 but less than 315, right? Like there's really not a specific way to say it, but there is an incorrect measurement, right? Like it's an incorrect position if you don't specify if it's in between certain numbers. So that's why I prefer just say a little less, so that I don't give any explanation of, okay, if it's between, if it's greater than, is it between something, or I can just leave my imagination of being greater than 300, so it could be like 500, right? You want to give a range so that we understand what we're talking about. So that's why, in my opinion, saying a little less is better, because you don't leave that room for speculation if it's in between two degrees. So pause right here and then go finish the rest of the problems. Once you are done checking, finishing the rest of the problems, then check your answers right here. 6 radians. 1 radian, and then here you have the rest of these. Okay, so I think with these you are ready to take your exit ticket. Oh no, I have one more here. Okay, now you're ready to take your exit ticket.